In this video, k is given by the square root of the square root of 7 plus the square root of 13. We want to find a and b natural numbers such that k is between a and b. And this difference between b and a, we want this difference to be the smallest possible. Okay, so we want to find a bracketing of k between b and a such this one will be the best possible. This is what this one means. Okay, because if we have a number, let's say 1.7, 1.7 is less than 2, less than 3, less than any other bigger number, but the best integer that's close to 1.7 is 2. So we call that the ceiling, but we are not going to use that here. Okay, so one key idea to solve this question is that we're going to use the fact that the square root is increasing. Okay, so if we have two numbers a and b positive such that a is less than b, then the square root of a is less than the square root of b. Okay, so this is key idea that we're going to use here. Graphically speaking, when we have the square root function, okay, we see that if we have a and b here, then the value, the square root of a, is less than the square root of b. That's what it means here. Okay, so we're going to use that one here, but we're going to work specifically with these numbers, square root of 7 and the square root of 13. To find positive integers a and b, we're going to try to find an upper bound and a lower bound for this one here. Okay, so first we're going to start with the square root of 7. Okay, that's the starting. So 7 is we're going to bracket this one in such a way that it is between two perfect numbers. Okay, a number that we can write as some a to the power 2. Okay, so here 7 is between 4, which is 2 to the power 2, and 9, which is 3 to the power 2. Now, when we take the square root, and remember what we said about the square root, that it's increasing, so we're going to have the square root of 4 less than the square root of 7 less than the square root of 9, and therefore the square root of 7 is between 2 and 3. I know that you know this, but this is just showing why. Because if we have bigger numbers, we can't say that that number is between this and that. Okay, next we're going to do the 13. 13 is between 9, which is 3 to the power 2, and 16, which is 4 to the power 2. And using the fact that the square root is increasing, we're going to have the square root of 13 is between 3 and 4. Now, if we add these two, okay, what we're going to have? We're going to have the square root of 13 plus the square root of 7 is between 7 and 5. Okay, and remember what we said about the square root that's increasing. Now, if we take the square root of this quantity here, we're going to have the square root of 5 less than the square root of 13 plus the square root of 7 less than the square root of 7. Okay, now we see that we are almost close to finding a and b integers that would give us the bounds for this quantity. Okay, so to find an integer here, we know that the square root of 5, we can do the same thing for it. So 5 is between 4 and 9. If we take the square root of 5, we're going to see that it's between 2 and 3. Okay, therefore, to find an integer that's less than this one, it's 2. So 2 less than the square root of 13 plus the square root of 7. And the same thing for 7. 7 is between 4 and 9. And if we take the square root, we're gonna see that it's less than 3. So therefore it's less than 3. And this gives us our A and our B. The last thing that we need to check is that B minus A must be the smallest possible. Okay? So if we take B minus A, that's 3 minus 2, that's 1. Okay? And this is the smallest, and this is the best that we can do using integers. This is the best way of bracketing this number using integers. To see why, let's see. So our number here, the square root of the square root of 13 plus the square root of 7. I don't know how much is that in the calculator. Okay, let me see if I have it in my calculator. Otherwise, I'm going to use my head. Okay, the square root of... Okay, let me do it here. Okay, so this is the value. Okay, so this is the square root of 7 plus the square root of 13. It's 2.5. Okay, so here, what this means is that we have, okay, so this is our K. Okay, we have found that this is 2, this is 3, and this is our K. Okay, so K is trapped between 2 and 3. There is no other integers, positive integers, that we can find that would bracket this one here. So we have found the smallest possible difference between these two, 3 and 2. There is no others. Okay, so K is, which is 2.5, is trapped between 2 and 3. Okay, this is a part of a larger and a longer problem, but this is the start to understanding how we can do this kind of bracketing. Okay, if you see any errors or mistakes, please let me know. So our A is 2 and our B is 3, and the smallest difference between 2 is 1. That means we have found the best bracketing. If we have found 4 here, okay, the difference, there is no small difference here between 4 and 2, because it's 2. It's not the smallest. The smallest is 1. Okay, that's what we mean by the smallest. Okay, anyways, if you see any errors or mistakes, please let me know. I didn't edit the video. Okay, thank you very much.